Okay, our weekly updates, and there are a lot of AI things happening. But first, I want to say a few words about May 1st, which apparently is celebrated in more than 160 countries, mostly as an International Workers' Day or Labor Day. In Germany, it is Der Erste May. It's an Asian festival to welcome the spring. So you see people dancing, spring weather, and drive away evil spirits. Uh, okay, so let's go through our program. First, I'll talk about Gradient.AI, and they created a version of Llama 3 with 1 million tokens context length, which is absolutely amazing. So what's happening with Llama 3, it was released two weeks ago. In the first week, more than 1.2 million downloads and more than 600 variations fine-tuned. And this continues, and the progress is absolutely amazing. So this is a great example. So they took Llama 3 and they fine-tuned it so it can work with 1 million tokens. I actually worked with it, downloaded on my work computer, which I'll show on the next slide. And yeah, and I exhausted the memory. So like you see, almost 100 gigabytes of memory. If you want, like I set it to work with 500,000 tokens. And yeah, and it took all, and I have a very powerful computer, 128 gigabyte memory. It's a latest MacBook Apple Silicone M3 MacBook Pro Max with 128 gigabyte of memory, and yeah, so it can handle it, which is amazing. It can work with it. Anyway, so excited to release first Llama 3 8B with over a million tokens on Hugging Face. It's all open source. So it extends Llama 3 8B, developed by Gradient, demonstrates state-of-the-art performance. This is link for the techniques they were using. And it's very easy to run with Llama. So Llama run Llama 3 gradient and then verbose, and then you just set parameter to the context length. So I set it to like 500,000, and that's how I did it. And here is testing of Llama 3 on Apple Silicon MacBook. I tested it on two MacBooks. One is 2-year-old, is M1 Pro with 32 gigabyte of memory, and another is M3 Max with 128 gigabyte of memory. And so these are also some other models I used. So I used the 70B instruct. I used Mistral 8 times 22 billion parameters. I used this huge gradient with, I mean, it's not huge. The model is small. Like I used here 6.6 gigabyte because I went not for 4-bit quantized by 6-bit quantized, just to get a little bit more quality. And then 8B instruct, again, Q6K. K is a way of quantizing using clustering, but these are all minor things. And then once in Llama, I set verbose and I set parameter number of GPUs to 999. Number of GPUs is how many layers of the model you put on GPU. Well, by default, Llama figures out and actually puts the whole model, but just in case I was setting this parameter, I don't have to do 999. You can do like 99 because usually the models have 30, 60, maybe 80 layers. So this is, of course, above. So my prompt was very detailed, just to make sure that different models behave in the same way. Please make a numbered chronological list of last 10 US presidents. Look back 50 years, make a list. The list should contain 10 rows. Important, make a fresh list. Disregard the chat history. Output only the list itself, nothing else. You see, like, I started with a short prompt, but then I added more details just to make sure that all the models behave the same way. And these are examples. So you see on M3, I can get up to 60 tokens per second. For regular Llama 3 8B. And then, well, it depends on the model. But, well, on M1, it is about twice slower. and all the rest are on M3. So you see, if I use the bigger model 70B, it is much slower, right? And so I really think it's better to use 8B models because they're fast and the quality is pretty good. Um, yeah, and by the way, on my M3 laptop, this is a disk speed test. So you see it's like 6 gigabytes per second. So here it's about 5 gigabytes per second, write and read. So it's a really, really fast. And this is the memory usage. So here I'm using a Llama 3 70B, and here I use 8 times 22B. It's a mistral. It's a big model. It's almost 80 gigabytes in memory. But if you look at OpenArena, mistral 822B is actually not as good as Llama 3 8B. So why would you use it? So what I found from experience, I'm very happy with Llama 3 8B, and then I can just decide on variation, whether I will use 4-bit or 6-bit, or maybe I'll use this gradient with extended context length. It depends on what you're trying to do. Okay, GPT-2 chatbot. Well, this was a mystery for 2 days. So what happened that this mysterious chatbot showed up on llm.c's org, and everybody went crazy about it, and there are a lot of videos people were doing testing, and it just blew everybody away because it was better than the best models we've seen before that. So people believed it was an early version of GPT 4.5. They checked how it works. Looks like it's coming from OpenAI. It's using OpenAI tokenizer. It gives OpenAI specific error messages and so on, so on. But it is better than GPT-4 and Claude 3 Opus. But then they removed it because LMCs, well, they allow developers to post models which are still in training just to check like where it stands, but in this particular case the traffic was so big so they just shut it down. But well, it just shows what's possible because this model was much better in math, it was much better in reasoning. It's just amazing. So it solved international math olympiad problem on first attempt, a competition where only top 4 US high school students qualify annually. It's exceeded GPT-4 and Claude Opus, which is the largest and greatest model. It's like benchmarks on complex coding prompts, used to model evaluation at AI startups like CodeGen, demonstrated iterative dialogue capabilities, self-awareness, and so on, exhibited rule-breaking behavior and willingness to solve logic puzzles, historically stamped GPT-4, matched and exceeded GPT-4 performance on ASCII art generation, which was really beautiful. It creates ASCII art, let's say, of a unicorn. Beautiful. Anyway, a lot of small updates on the next 3 pages. So ChatGPT now has permanent memory feature. So you could tell it about your preferences, and then next time you don't have to repeat it, already knows it about yourself. And you can selectively add or remove things to this memory. System prompts for GPT, Gemini, and Claude. So this is an interesting article where they describe how you can extract the system prompts. Amazon Q Business. Well, this is AI assistant, which is well very good for business, and it's provided by Amazon. So it can answer questions, provide summaries, generate content, securely complete tasks, and so on. And yeah, it's a good out-of-the-box solution which Amazon provides. Claude on Apple App Store. So now on Apple Store you have another app, and this is a Claude model. GitHub Copilot Workspace. Well, it's in preview, but it's a new service from GitHub, and it can be directed by prompts to actually create the software from scratch. So usually when people think about GitHub Copilot, they think about something which helps you to refactor or do like tab completion or add a commentary or comment to your code, something small, make a small function. But here you can actually talk to it to create architecture for your project, create step-by-step plan, and then to execute it. So you don't need to code yourself, and this I think it's amazing. Anyway, 8 major U.S. newspapers sue OpenAI and Microsoft. You know, New York Times started this, and now another 8 Newspapers are suing them for using copyrighted materials illegally to train models, chatbots, and Copilot. Mistral.rs, I want to try it. This is in my to-do list. So this is LLM inference using Rust, as you understand from extension arrest. So it works on a variety of devices. It's very fast. It provides easy to use HTTP server and Python bindings. Great. More, Vidu. This is the new Chinese text-to-video AI competitor to OpenAI's Sora. You remember Sora was creating high-quality videos about 1 minute long, like this. Please mute yourself. Who joined? Please mute yourself. It can create 16-second video in like a good resolution, and you can read about it and you can watch the video demonstrations. Andrej Karpathy always invents something interesting. So now what he was talking about is that the code he wrote, this is on GitHub called llm.c. Remember, he's re-implemented GPT-2 in just 1,000 lines of C code, and then people joined and they added another 1,000 lines to add CUDA, and so now you have just 2,000 lines of clean C code. And what he says is then you can harden it, add comments, add tests to pass NASA code standards, and then, well, you can use it in space. I don't know, maybe to coordinate research or do something, but this is a great idea. The code is compact and it's actually doable now. Andrew Ng, famous, Stanford professor, and well, anyway, what he was writing about, it's a very interesting idea. So you know how you can ask questions to a good model like ChatGPT, or GPT model. You can get questions and answers, and then you can use these questions and answers to train a smaller model. But the question is, well, can you use this data to improve the ChatGPT itself? And the answer is no, you can't. But if you use agents, then suddenly you can actually create question-answer pairs which could be used to improve the original LLM. And this is a very interesting perspective. So he wrote about it, and this is his Twitter post. Realm survey, retrieval augmented language models. So this includes RAG, which is retrieval augmented generation, and RAW, which is retrieval augmented understanding. And they talk about ways to improve, test, and so on. This is an article, this is a review, very interesting, highly recommend. Better and faster large language models via multi-talking prediction. Very interesting idea. So usually LLM, the way it works, it predicts one token at a time, right? But here they predict several tokens in parallel. At each position in the training corpus, we ask the model to predict the following n tokens using n independent output heads operating on top of the shared model trunk. New approach, very promising. This is the picture kind of demonstrating it, and apparently it works better. Llama 3 is available on, well, everywhere. So on Amazon Bedrock and SageMaker and Azure, Google Cloud, Hugging Face, Grok, you name it. Everywhere. Everybody is providing it. Med-Gemini from Google. So what they did, they created a family of Gemini models which are fine-tuned for medical tasks, and they behave better than GPT-4 and other models, but the main competitor was GPT-4. On all benchmarks, what they meant is medical benchmarks. And so these are the paper, and from Google, it's like 67 authors. It's, well, yeah, it's a big achievement. You have the best AI doctor now is this Med-Gemini. Dilated attention. So people are fighting to get a bigger and bigger context length. And now they're scaling to 1 billion tokens. Well, it's not achieved, well, it's whatever, but at least the technology how to do it is being developed. So it's inspired by dilated convolutions in convolutional neural networks, allows tokens to attend to other at increased distances. There is a parameter called dilation factor, so you can specify like the length of the jumps. There are multiple layers, how it works. But anyway, so this is just remember the term dilation attention. I think you will hear it more. Sam Altman, there was an interview at Harvard, and there was a question answering also at Stanford. So interesting. He called the GPT-4 mildly embarrassing at best, saying it will be the worst model we will ever use. At each new version gets smarter. So he hinted about the new model being released and so on. He said that he doesn't care whether the company burns $500 million or $50 billion a year, as long as it stays on the trajectory of creating a GI, it will worth it. He also spoke about the importance of global access to compute, starting the mission to make GPT free for everybody who wants it and needs it. He also revealed that the mysterious GPT-2 chatbot, which I was talking about earlier, that it is not GPT 4.5. It's something different, but well. And there were also conversations that something will be revealed in the middle of May on Google event. Hello, do you hear me? Hello?
Yes.
Yes, good, thank you. Okay, next, Google has introduced a new functionality in Chrome. So the way it works, you just type @ and then you see this selection. So for example, you can say chat with Gemini, and then you can ask why sky is blue, and it will answering. Well, in my case, it understood that I have Gemini account, and it gives me answer here. But everybody can use it, I think. Next is Adv Prompter. This is fast adaptive adversarial prompting for LLMs. So these are researchers from Meta, and they created a way to generate adversarial prompts very, very fast, like you see, 800 times faster. So this is a way to train and to make the models more secure. Another interesting development, research from Google, and this is about graphs. So trillion edge graphs. Well, they are on the path to be able to handle this. And so this is the research paper about it. Okay, next is AI safety board, and this is really embarrassing. So what's happening is, well, the government, US government, understands that the AI may be dangerous, right? And they, of course, then tasked Homeland Security to make sure that AI will not cause any harm to the country. So this is strategical. So you see, DHS, which is Department of Homeland Security, facilitates the safe and responsible deployment and use of AI in federal government and critical, like whatever, protecting water supplies, power grids, telecommunications, other critical infrastructure, AI-enabled threats, incorporating AI into carrying out Homeland Security mission for safe, responsible, trustworthy use, and ensuring economic security, and so on. This is all very important and very true. What I think is embarrassing, so they created something called AI Safety and Security Board, which has 22 members. And you see I marked in red like positions as CEO, and you see this is mostly just CEOs of different corporations, right? All kind of corporations, and there are some other people like governor, assistant to president, and the only scientist is here. It's Fei Fei, so she's from Stanford. She is of course very famous, but I don't see Yann LeCun. I don't see Mark Zuckerberg. I don't see Elon Musk. I don't see so many other great people in America. They are not included. They are not invited to the table. They are completely ignored, and this is very strange because it looks like these big corporations starting with OpenAI and Anthropic and, well, Delta Airlines. Why Delta Airlines? And, because it's strategic aviation, maybe, I don't know. And Microsoft, of course, Satya Nadella and Adobe and so on. But no open source, and open source is taking over, and it's not represented in this board at all. So big corporations are basically captured this executive power, and this is exactly what Elon Musk was against, right? That's he was afraid that this might happen if AI will be in the hands of big corporations. Anyway, this is a very interesting picture. I really like it. So it is by Bill Gurley, who is an investor, venture capitalist, and so what is really happening in the background around AI regulation? And this is his post on Twitter, and this picture from this post. So promote that LLMs are magical, blah, blah, blah. So use this unlimited potential to raise money, pass millions to employees, use big payouts to retain talent and hire more engineers, build hyperbolic demonstrations, demos, and so this is this cycle. This is one cycle. And this is another cycle. Intentionally stoke fear in the world about possible negative outcomes, encourage legislation, use legislation to cut off open source competitors, and then of course hire and continue the cycle. So you have these two cycles, and you see what just happened is this capture of legislation by big corporations. Anyway, Yann LeCun, well, beloved legend Yann LeCun, just to remind, he was the first who created large language model in production in Bell Labs, convolutional neural networks. He's a legend. It was more than 30 years ago. He is in NYU in New York. He is also leading the AI research at Meta. And he talks about large language models that he believes they are not logical. They cannot reason, they cannot plan. We need another architecture. But there's a couple of Twitters, and he says, you see, how to be smart as autoregressive LLMs. That's what we have today. Memorize lots of problem statements together with recipes, how to solve. To solve a new problem, retrieve the recipe which is superficially matches the new problem and apply the recipe blindly and declare victory. So this is how large language models work today. Do not use basic logic. Do not use common sense to check your solution. Do not use mental model of the situation as a sanity check. Do not simulate the scenario in your mind using the world model. When someone tells you your solution is wrong, reply, I am sorry, you're right, and apply another irrelevant recipe. So yeah, this is our daily experience with large language models. Knowledge accumulation is not a substitute for actual understanding. I am pointing out that merely scaling LLMs will not lead to human-level AI. I don't hate LLMs, they're useful. Some of my best friends are LLMs. LLMs are flawed but useful in short terms. FAIR, which is Facebook AI research, is working on the next generation of AI systems. Yeah, and this is a beautiful picture of a Llama model. LLM's key terminology. I found this good article where the author introduced something like 25 different terms which are often used, and if you were following these my videos, you've heard these terms multiple times. Like LM, it's language model, LLM is large language model, training LLMs, fine-tuning LLMs, parameters of the models, vector, like embedding vectors, embeddings, tokenization, which is splitting text into small pieces, usually about 4 characters is 1 token, and about 4,000 tokens is about 6 pages. Transformer architecture, attention mechanism, we remember coming from Google in 2016-17. Inference, which is when the model is already trained. You give it something and it makes predictions, answers your question, and so on. Temperature is one of the hyperparameters of the model. The higher the temperature, the more random and unpredictable is the response. Frequency, a parameter which adjusts the likelihood of tokens based on the frequency of occurrence. So it may become more like common versus rare. Sampling, generating text by randomly picking the word based on its probability distribution. Top K sampling, model of choice for the next word, is limited to the K most likely next words. RLHF, reinforcement learning from human feedback. This is used by all large models to make the models better using human feedback. Decoding strategies determine how language model selects output sequences during generation. It may be greedy decoding or beam search. This is what happens at the very end of the structure. So you have input of tokens, you convert them into vectors, and then they go through the layers of the model, and at the end it predicts next token, and then it goes to the beginning and the cycle repeats. So how you find this next token? This is we're talking about decoding strategies. Prompt engineering, well, you know, designing inputs for the models. Transformer Excel extends the existing transformer architecture, enabling learning dependencies beyond a fixed length. MLM, masked language modeling, train the model to predict masked input segments. So you mask a piece of text and then the model needs to predict it. This is actually used anyway. Sec to sec, sequence to sequence models convert sequences from one domain to another, usually have encoder decoder. Typical example is the translation between languages, converting questions to answers, and so on. GPT, generative pre-trained transformer. Well, this is OpenAI models. Perplexity related to predictive accuracy. Low perplexity suggests superior prediction of test data. Multi-head attention, used in all models, enables the model to focus on various representation subspaces in different positions simultaneously. So you have multiple heads. Contextual embeddings, dynamic embeddings that consider the context, which is surrounding text. And autoregressive models, well, these are our large language models. These are just autoregressive statistical models. And we have something else. We have Kolmogorov-Arnold networks. So this is a picture of Kolmogorov, this is Arnold, and this is network. Although Kolmogorov-Arnold network is something completely different. And this is a new work coming from MIT, and this is some links. So first of all, neural networks can approximate any kind of function, any kind of model. Like to understand it easily, you can, let's say you have any kind of function. So y is a function of x, and you can represent it as a sequence of many delta functions, like many rectangles with different height, with different coefficients. So the output is just a sum of these delta functions, right? And or you can think about in terms of step functions. Anyway, so there's like a simple theorem of that network can predict any function. But what Kolmogorov-Arnold is doing is a little bit different. So they say, suppose you have any kind of continuous function of different variables from x1 to xm, right? You can present it in this way. So you have two functions, rho and theta, or phi, whatever, and phi of one x, right? And then you combine them with different weights and you sum them, so it's additive. And you can present any arbitrary function f in this. So you just need two functions, rho and theta, and you have additive sum in the middle. It's kind of analogous to Fourier distribution, but this is more general. And you can, like, if you think a traditional neural network, which is multi-layer perceptron. So information moves like this. You see through layers. moves in layers, like building upwards. Each neuron does a very simple calculation, which is just calculate the sum of inputs and then passes it to the next layer, also multiplying by some nonlinear function. So that's all standard neural networks do. Kolmogorov-Arnold network is different. So information flows along connections between pieces, like putting a puzzle pieces together. Each connection has its own function, like a strangely shaped puzzle piece that changes the information it connects. So it's a different architecture. I asked Gemini to explain to me the Kolmogorov-Arnold representation, and it like made a picture. So imagine you have a big box full of all sorts of colorful building blocks. The Kolmogorov-Arnold representation theorem says that no matter how complicated the building you can make with those blocks, you only need two special moves. One move is this, and another move is this. So you can use single colored blocks, like only blue blocks or only green blocks. So this is what you're doing here. And then you can stack these single colored blocks uh, on top of each other, and this is applying this function. So two steps. You combine some similar blocks together, and then you add them together, and you can build whatever you want. So this is Kolmogorov-Arnold networks. Anyway, so this is a new architecture, this is a new approach, and this is coming from MIT. Very, very interesting to see where it will go. Another interesting notion, longevity escape velocity. I love Ray Kurzweil. So this was from a recent interview. So what is longevity escape velocity? Today, by some estimates, science is adding about 3 months of your lifespan every year. So in the near future, at some point, additional scientific breakthroughs will extend your lifespan by more than a year for every year you remain alive. So that means that if you don't get into accident, you theoretically can live forever, right? And when it happens, we have reached longevity escape velocity. So the question, when we might reach this longevity escape velocity? Right now, we're at about 1/4 of it. And his answer was sooner than you might imagine. For those in reasonably good shape and with reasonable means, I believe they will have access to longevity escape velocity by the end of 2030. Well, interesting. So, well, be in good shape. Okay, Demis Hassabis and Mustafa Suleiman. So these are two people who are on top. Like Demis Hassabis is Google. He's DeepMind. So this is research, AI research at Google. And Suleiman, he was recently pulled into Microsoft. So he's chief executive of Microsoft overseeing consumer products. What's interesting that they both come from England, from London, and they both knew each other then when they were kids. And so, yeah, this is a very interesting article at New York Times, which talks about it, about their history. Another interesting thing for those of you who are in New York, there is a play which is called Scarlet Dreams. And it talks about so there are only 4 actors in, and they use a lot of projections, and it's a lot of fun, and it's very energetic and musical. So people who watched it highly recommend to actually go there. The tickets somewhere between $60 and $100. And the plot is that two siblings, Milo and Lisa, created a fitness app which is called Real Fit, and it's a virtual reality. It has this trainer, which is in this case a virtual young woman, who trains this person who is a husband of Miller. So they convinced him to become a beta tester, and as a result, he got addictive. He got, I don't know, in love with his virtual trainer, and which kind of destroyed his relationship with his girlfriend. and the AI app begins to change the world as they know it by changing people's motivations and destroying relationships. But well, definitely interesting. They were not the first who touched on this theme, but I guess it's a good play. I couldn't find the recording of it, so you have to actually go there and watch in person. Open source growth recently, what it is? Why it says 2000? This is wrong. 2019 and this is 23. So you see the growth of a number of foundational models, and you see the dark green, it's open source. So you see open source is definitely taking over, and this is by results of 2023. So now it's even more. Now what here we see average of top scores on human baseline over time, and this is from September last year till now. And you see it kind of plateaus, not reaching the human level, but becoming very high. And this is top scores on human baseline over time from, again, September to May 24. So you see what's happening, that all the models and on all different tests, they become very good. Like they close to human. Which is very impressive. And here I try to collect some statistics. So first of all, the number of models right now on Hugging Face, which is overwhelmingly open source models, is 635,000 models. I remember in January it was about 300,000, so it's like doubled in just next month, in a few months. For text generation, it's 88,000. I remember it was 20,000 something in the summer. I remember the leaderboard was only 330 or 50 models before Llama 2 was introduced in July. So this is tremendous growth. Text classification about 60,000, text-to-text generation about 30,000, data sets 140,000. It was about 60,000 in September. I wish I had historic numbers, but I couldn't find them. But I just remember like what it was, and it's tremendous growth. Okay, this is Crowdsourced Arena leaderboard, where we use LO ratings, and this is only for English-only queries. Just to remind, like if you go to the arena, so I go there right now. You will see the overall statistics, right? And you'll see a lot of these models. So now it's 92 models, and you can change from overall to English only, because this what interests me. And what you can see that on the top, you see GPT-4 and Gemini, and then suddenly you have Llama 3, 70B, which is quite high. And then you see Llama 3 8B, which is a very small model. But again, it's amazingly high in the whole big list of all these models. So my advice, just use Llama 3 8B and you'll be golden. It's a very small model, and because it's small, it's very fast. It's free, it's open source. Amazing. So these are these two models with red circles. Quite amazing. And by the way, the GPT 3.5, it's only on 27th place. And this is in English-speaking models. If you expand to it will probably go even lower. Okay, next is about job search. You know, for many years I was a consultant and I was getting a lot of jobs through LinkedIn, and I was advising people to use LinkedIn to get jobs, but I cannot advise you to do it anymore because it doesn't work at all. And so what's happening is that AI bots are now flooding job postings with applications. And what they do, they take the job posting, they take your resume, they modify your resume to add more keywords to match the job description, and then they submit it. And they could submit hundreds of resumes per hour, and if you multiply it by the number of people, suddenly all these jobs are flooded with resumes. And poor HR people, poor internal recruiters, now they have to deal with these hundreds of thousands of resumes. They, of course, try to use some sort of technology, AI, to figure out which one to choose. And of course, what they will find on top are the best matching one. And the best matching one will be the one which are created by AI bots. So it's no winning game. So what's the advice? Just start talking to humans. Start networking, meet with people, meet up groups, conferences, organizations, call the recruiters yourself, find their websites, call them human to human. So we're returning to human to human. Getting a job, it's a human to human sale. And so we're going back to basics. What I also recommend is to add more to your packaging. You'll be surprised. Most of the people still don't have even their own website. They have a LinkedIn profile and that's it. So if you have your own website, if you have some articles, videos, books, GitHub, personal website, so you will stand out. Just try to stand out and try to use human to human networking. And so these are some links which talks about it. These are some pictures, people drowning in the resumes and automatic creating resumes. And another interesting thing actually coming from White House. So there was a press release where the national cyber director was talking when trying to find people, not rely on their titles, but just find skills, skill-based hiring. So this is a new thing. And by the way, Elon Musk was talking about it for a long time. He was saying that for him, somebody having a diploma is not a positive thing, but a negative thing, because he believes the diploma doesn't help. He just wants to find people who have skills and who have experience and knack to resolving problems, to figuring out things. Anyway, this is the regular updates about technical layoffs. So this is 2023, this is 2024, so number of layoffs is smaller. This is me, nothing changes here, and thank you. Did I stop it?